Dear students, yesterday we discussed about some properties and definitions. So today I continue the class about the previous class. So today I am telling the property of closure property. Closure property nothing but binary operation. So but we know what is the binary operation. So now I am telling the definition of closure property. Let S be a non-empty set and star is a binary operation. If for all a comma b belongs to S, that implies a star b belongs to S, then we say that S satisfies closure property with respect to binary operation. So it means if we have to take any non-empty set and take any two elements in the set, so apply the binary operation, so it will come, result is becomes to belongs to S, then that star is called binary operation. For example, let's consider S equal to natural number set. So S equal to n equal to set of 1 comma 2 comma 3 comma and so on. Now take star as plus. So now 5 comma 6 belongs to n, that implies 5 plus 6 equal to 11. So 11 is also natural number. So that's why 11 belongs to capital N. So now here N satisfies closure property with respect to binary operation plus. So similarly W, Z, Q, R are also satisfies closure property with respect to plus, because of N is a subset of W and W is also subset of Z. So W is also subset of Q. Q is subset of R. So that's why here also W, Z, Q, R are also satisfies closure property with respect to plus. So I am giving another example here. Let consider S equal to natural number set as N, S equal to N, the set of 1 comma 2 comma 3 comma and so on. Now take star as minus. Here star equal to minus. Now take any two elements in N. I am taking here 1 comma 2. So 1 comma 2 belongs to N. That implies 1 minus 2 equal to minus 1. But minus 1 is not belongs to capital N. So minus 1 is not a natural number. So because of natural numbers starts with 1, 2, 3 and so on. So minus 1 is not belongs to capital N. So now here N does not satisfy the closure property with respect to minus. So now W is also not satisfy closure property with respect to minus, because of W is also not containing negative values. Now goes to another number system. After W we get the number system Z. So let consider S equal to Z, and here also star consider as minus. So now 1 minus 2 belongs to Z. Now 1 minus 2 equal to minus 1. So here minus 1 belongs to Z. So Z as containing negative and positive values including with 0. So minus 1 belongs to Z. So now here Z is satisfies closure property with respect to minus. So Z belongs to Q and Q belongs to R. So that's why Q and R also satisfies closure property with respect to minus. So now I am giving another example. Third example. Let's consider S equal to N. So N means N is a natural number set. N means natural number set. So S equal to N equal to set of 1 comma 2 comma 3 comma and so on. Now here I am taking star equal to into multiplication. Now let us take any two elements in n. I am taking here 3 comma 4. 3 comma 4 belongs to capital N. So that implies 3 into 4 equal to 12. So 12 is also a natural number. So 12 belongs to capital N. So that means here n is satisfies closure property with respect to into or dot. Dot means multiplication. So n is satisfies closure property with respect to dot or into. So similarly, n is also subset W. Here W is subset Z. Z is subset Q. Q is subset R. So that's why W, Z, Q, R. All are also satisfies closure property with respect to multiplication or dot. So I'm going to another example here because binary operation. I'm taking another binary operation here. Now let's consider s equal to natural number set n and star equal to divide here. So 3 comma 4 belongs to n. So 3 divides 4 equal to 3 by 4. So 3 by 4 is not a natural number because 3 by 4 is a rational number. 3 by 4 is a rational number. So 3 by 4 does not belongs to n. So after n, we get the whole number set. So whole number set is also not containing rational numbers. So q is not q and z. Z is a integers. Integers means it has negative and positive values including with 0. So similarly here WZ also does not satisfy closure property with respect to divide. So here star equal to divide is not satisfies closure property with respect to divide. So after Z tarata we getting here number system is Q. So now let's consider S equal to Q. Q means Q is a rational number set. Rational number set denoted by Q. Q equal to set of P by Q such that P comma Q belongs to Z. Q not equal to 0. Here star equal to divide. So now 3 comma 4 belongs to Q. So that implies 3 by 4. So 3 by 4 is in the form of P by Q and 3 comma 4 are the integers. So 3 by 4 belongs to Q. So Q is satisfies closure property with respect to divide. So Q is belongs to R. So R is also satisfies closure property with respect to divide. So I given 4 examples on 4 operations plus, into, minus, divide. So I am going to another property after closure property. Another property is associative law or associative property. Associative law or associative property. So what is the associative law here? See here, let S be a non-empty set and star be a binary operation if A comma B comma C belongs to S. That implies A star of B star C equal to A star B of star C. Then we say that S satisfies associative property with respect to star. So let's consider S is a non-empty set and star is a binary operation on S. I am taking here any 3 elements in S. So A comma B comma C belongs to S. Now applying satisfies this property. What is the property here? A star of B star C equal to A star B of star C. So then star is a associative on S. For example, I am giving here example. Let S equal to, let consider S equal to a natural number set. So that's why S equal to n equal to 1 comma 2 comma 3 and so on. Now I am here taking binary operation star equal to plus. So star is there considered as plus. So now I am taking 3 elements here. So the 3 elements are 9, 11, 13 belongs to n. Now I am verify the condition of associative law here. 9 plus of 11 plus 13 equal to So within the bracket of 11 plus 13 is the 24. Now 9 plus 24 is equal to 33. This is the LHS value of the property of associative condition. And RHS value is here 9 plus 11. 9 plus 11 is 20. 20 plus 13 equal to 33. So here both left side value and right side value both are equal. So 9 plus of 11 plus 13 equal to 9 plus of plus 13 is equal. So it is satisfies associative law. So n satisfies associative property with respect to plus. So n is satisfies the associative. So then similarly v, w, z, q are also satisfies associative property with respect to plus because of n subset w, w subset z, z subset q, q subset r. So this is the by associative property satisfies with respect to plus. Now another example, second example, I am taking here star equal to as minus. So let s equal to n equal to 1 comma 2 comma 3 and so on. So same values I am taking here 9 comma 11 comma 13 belongs to n. So 9 minus of 11 minus 13 equal to. So 11 minus 13 is minus 2. So 9 minus of minus 2 equal to 11. The 11 is the LHS value. And 9 minus 11 equal to minus 2. So minus 2 minus 13 equal to minus 15. This is the RHS value. But here LHS value and RHS value does not equal. So both are different values. We get here both are different values. So that's why I am telling here n does not satisfy associative property with respect to minus. N does not satisfy associative property with respect to minus because of it is not satisfy the A star of B star C equal to A star B of star C. So here star equal to minus. So similarly, W is also not satisfy associative property with respect to minus because of the above three values all are also belongs to W. So similarly, Z, Q are also not satisfy associative property with respect to minus. So give these are all not satisfied because of we get the different values with respect to you can you can take the any natural numbers or integers any rational numbers any real numbers you can take and verify that condition we get the we did not get the same values. So n, w, z, q r all are not satisfies associative property with respect to minus. Now, but I am giving here example for associative property with respect to minus. మైనస్ దృష్ట్యా సహచర న్యాయాన్ని పాటించడానికి ఒక ఎగ్జాంపుల్ నేను ఇక్కడ ఇస్తున్నాను. ఐఎమ్ టేకింగ్ హియర్ s ఈక్వల్ టు సింగిల్ సెట్ ఆఫ్ 0. సో s ఈక్వల్ టు సెట్ ఆఫ్ 0. సో హియర్ s is a 0. So here s equal to single set of 0 and star equal to minus. So s is as single element. A single element is a 0. So we have to take three elements. Three elements means you can repeat the single element. 0 comma 0 comma 0 belongs to s. That implies 0 minus of 0 minus equal to 0. This is the LHS value. And right side value is the 0 minus of 0 equal to we get here also 0. So that's why I am telling here LHS and RHS value both are same because of here s is there only has 0 value. So s is satisfies associative property with respect to minus. సున్నాను కలిగినటువంటి 0 ఏకైక మూలకంగా కలిగినటువంటి సమితి మైనస్ దృష్ట్యా సహచర న్యాయాన్ని పాటిస్తుంది అన్న దానికి ఒక ఉదాహరణగా చెప్పవచ్చు మనం ఇక్కడ. సో s is satisfies associative property with respect to minus. Now associative property ke another example here. S equal to n equal to 1 comma 2 comma 3 and so on. Now binary operation star as consider dot. Dot means multiplication. So 9 comma 11 comma 13 belongs to capital N. So 9 into of 11 into 13 equal to 11 into 13 is 143. So 9 into 143 is we getting here 1287. It is a LHS value. So left side value. So now right side value here 9 into 11. 9 into 11 of 13 equal to 9 into 11 is 19. 99. 99 into 13 is equal to 1287. So here LHS and RHS value both are same. So multiplication is satisfy the associative property on n. So n is satisfies associative property with respect to dot. So n is satisfy the associative, then we say similarly W, Z, Q, R are also satisfies associative property with respect to dot. Since because of n subset, W subset, Z subset, Q subset, R. So multiplication is a associative property on n. So fourth example. So I am taking here s equal to n equal to 1, 2, 3 and so on, natural number set, and star divide is a consider binary operation as star equal to divide. So 9 comma 11 comma 13 belongs to n. 9 comma 11 comma 13 belongs to n. So 9 divided equal to 117 by 11. It is a rational number, but does not belongs to n. So after that 9 divide 11 divide 13 equal to 9 by 11 divide 13. So 9 by 143. So both are not same numbers. LHS value is the 117 by 11 and RHS value is the 9 by 143. So both are different values. So LHS not equal to RHS. So N is not satisfy the associative property with respect to divide. And I'm going to another number system. After N tarata we get here W. W is also and Z is also W is also not satisfy associative property. Similarly, Z, Q, R also does not satisfy associative property with respect to divide. Because of you can the above examples is considered as the belongs to W, Z, Q, R. So, but I am giving here one example for satisfy the associative property with respect to divide. భాగాహారం దృష్ట్యా సహచర న్యాయాన్ని పాటించడానికి ఒక ఉదాహరణ నేను ఇక్కడ ఇస్తున్నాను. ఐఎమ్ టేకింగ్ set here s equal to single set of 1 and star equal to divide. So now I am s as a single element. It is a 1. So 1 comma 1 comma belongs to s. Now LHS value is the 1 divide of 1 divide 1 equal to 1 divide 1 equal to 1. So LHS value is the 1 and RHS value is the similarly we get the 1. So both are same value. So now S is satisfies associative property with respect to divide. అంటే భాగాహారం దృష్ట్యా S అనేది సహచర న్యాయాన్ని పాటిస్తుంది. ఎప్పుడు S ఈక్వల్ టు ఏకైక మూలకం ఒకటిని కలిగినప్పుడు మాత్రమే అది భాగాహారం దృష్ట్యా సహచర న్యాయాన్ని పాటిస్తుందని చెప్పడానికి ఒక ఎగ్జాంపుల్ గా చెప్పవచ్చు. కానీ సహచర న్యాయానికి అక్కడ 0 చెప్పవచ్చు మనం దేంట్లో వ్యవకలనం దృష్ట్యా. So it is a associative. Associative property is condition is A star of B star C equal to A star B of star C. So ఏ నెంబర్ సిస్టమ్ అయితే ఈ కండిషన్ సాటిస్ఫై చేస్తుందో ఆ నెంబర్ సిస్టమ్ మనం అసోసియేటివ్ ప్రాపర్టీని సాటిస్ఫై చేస్తుందని చెప్పవచ్చు. సో ఆఫ్టర్ అసోసియేటివ్ లా we go to another property or definition of law. So another property is here identity law. So it is the most important property, identity law or identity property. Let us take S be a non-empty set and star be a binary operation. Then there exists E belongs to S. Then there exists E belongs to S such that A star E equal to E star A equal to A for all A belongs to S. Then we say that S satisfies identity law with respect to star. Observe here, what is the condition here? What is the condition here? Then there exists E belongs to S such that A star E equal to E star A equal to A for all A belongs to S. Then we say that S satisfies identity law with respect to star. S ఏదైనా ఒక శూన్యేతర ఉపసమితి S పై స్టార్ ఒక యుగ్మ పరిక్రియ అనుకున్నప్పుడు S లోని ప్రతి మూలకానికి ఆల్ A belongs to S కు A star E equal to E star A equal to A అగునట్లుగా E అనే మూలకం S లో వ్యవస్థితం అయితే S లోని ప్రతి మూలకానికి A star E equal to E star A equal to A అగునట్లుగా S లో E అనే మూలకం వ్యవస్థితం అయితే S అనేది తత్సమన్యాయాన్ని పాటిస్తుంది అని అంటాము. S అనేది తత్సమన్యాయాన్ని పాటిస్తుందని అంటాము. For example, here I am giving one example here. Let's consider n equal to n is the natural number set. N equal to 1, 2, 3, and so on. And now take star as plus. Here binary operation is plus. So there exists E equal to 0 belongs to n such that A plus 0 equal to A. So natural number set loni ఏ మూలకానికైనా మనం 0 యాడ్ చేస్తే we get the same number. But here 0 does not belongs to n. So n does not satisfy the identity property with respect to plus because of here 0 is not a natural number. So సహజ సంఖ్యా సమితిలోని ఏ మూలకం తీసుకున్నా ఆ మూలకానికి సున్నాను కలుపుతేనే మనకు అదే మూలకం వస్తుంది. కాబట్టి A plus 0 equal to A. So here star equal to plus. So A belongs to n. But here in place of E equal to we getting here 0. But 0 does not belongs to n. So that's why n does not satisfy identity property with respect to plus. So but whole number set starts with 0. So whole number set W equal to what? 0, 1, 2, and so on. Now I am taking here star equal to plus. But here 0 belongs to W. So W లోని ఏ మూలకానికైనా సున్నాను కలిపితే మనకు అదే మూలకం వస్తుంది. So E equal to 0 belongs to W such that A plus 0 equal to 0 plus A equal to A. So W లోని ప్రతి మూలకానికి సున్నాను కలిపితే మనకు మళ్ళీ అదే మూలకం రిపీట్ అవుతుంది. కాబట్టి W satisfies identity property with respect to plus because of A plus 0 equal to 0 plus A equal to 0, and here A belongs to W, and at the same time existing value. What is the existing value here? 0. So 0 also belongs to W. So W satisfies identity property with respect to W. So here and identity element in W with respect to A, which is the identity element here means 0 is the identity element because of you can add the 0 to any element, we get that number. So now 0 is the identity element in W. So similarly we can say Z, Q, R are also satisfies identity property with respect to plus, and identity element is 0 because of W subset, Z subset, Q subset, R. So identity element with respect to addition is 0. So 0 is the identity element with respect to addition. 0 is the identity element with respect to addition. So after binary operation, I am taking in examples plus here, but I am taking binary operation minus here. So N, W, Z, Q, R does not satisfy identity property with respect to minus because of there is no exist identity element in N, W, Z. So now I am taking S equal to 0 and star equal to minus. Star equal to minus. So there exists E belongs to S such that 0 minus equal to 0 minus equal to how much? 0. So single set of 0 is a satisfies identity property with respect to minus. So here 0 is the identity element with respect to 0. So now I am taking binary operation as multiplication. So n equal to 1 comma 2 comma 3 and star equal to, let us consider as dot or multiplication into. So then there exists here, then there exists E belongs to N such that A dot 1 equal to A dot 1 equal to 1 dot A equal to A for all A belongs to N. ఎన్లోని ప్రతి మూలకాన్ని 1 తో మల్టిప్లికేషన్ చేస్తే మనకు మళ్ళీ అదే మూలకం వస్తుంది కాబట్టి in place of e equal to here 1, so 1 is the natural number, so 1 belongs to n, so 2 into 1 equal to how much? 2 equal to 1 into 2 equal to 2, and similarly we can put the any value in n, multiply with 1, we get the same value. So 11 into 1 equal to 11, 1 into 11 equal to 11. So here 11 belongs to n and 1 belongs to n. So you can multiply with another without 1, you can multiply ఒకటి కాకుండా ఏదే మూలకాయంతో మల్టిప్లై చేసినప్పుడు 11 into 2 equal to how much ఇక్కడ 22 and 2 into 11 equal to 22, but we are getting the here different value, but 22 is a natural number, but what we will get here? A star equal to E star A equal to A, same value రావాలి, but you are getting the another value. So here 2 is not a identity element with respect to multiplication, but 1 is the identity element with respect to multiplication. So 1 is a identity element with respect to multiplication. గుణన దృష్ట్యా తత్సమ మూలకం 1. So n is satisfies identity property with respect to multiplication and identity element is the 1. So similarly W, Z, Q, R all are also satisfies identity property with respect to multiplication because of here n subset, W subset, Z subset, Q subset, R, and identity element is the 1. So most important point here, identity element with respect to multiplication is 1, identity element with respect to addition is 0. So సంకలన తత్సమం 0, గుణన తత్సమం 1, గుణన తత్సమం 1, సంకలన తత్సమం 0. So after multiplication, another binary operation we have here divide, but star equal to divide, but n, w, z, q, r also does not satisfy the identity property with respect to divide. So but only one example for identity property satisfies with respect to divide. What is the set is the here? I am s equal to single set of 1, s equal to single set of 1 is satisfies identity property with respect to divide because of here S is containing only single element, that element is only 1. So 1 divide 1 equal to 1, 1 divide 1 equal to 1. So here only one element, it is a 1. So S is satisfy identity property with respect to divide and identity element is here 1. So most important point here, identity element with respect to addition is 0. సంకలన తత్సమం ఎల్లప్పుడూ 0. అలాగే ఐడెంటిటీ ఎలిమెంట్ విత్ రెస్పెక్ట్ టు మల్టిప్లికేషన్ ఈజ్ 1. గుణన తత్సమం ఎల్లప్పుడూ 1. ఎందుకనగా ఏదైనా ఒక మూలకానికి 0ను కలిపితే మనకు అదే మూలకం వస్తుంది. కాబట్టి 0ను మనం సంకలన తత్సమం అంటాము. You can add any element with 0, we get the same element. A plus 0 equal to 0 plus A equal to A. అదేవిధంగా ఏదైనా ఒక మూలకాన్ని 1తో గుణకారం చేస్తే మనకు అదే మూలకం వస్తుంది. కావున 1 అనేది గుణకార దశమం. You can multiply any element with 1 by 1. We will get the same value. So A dot 1 equal to 1 dot A equal to A. So 1 is the identity element with respect to multiplication and 0 is the identity element with respect to addition. So it is the identity law. So another law, inverse. So inverse law. So inverse law is relation with identity law. So తత్సమ ధర్మంతో ఇది సంబంధాన్ని కలిగి ఉంటుంది. So first of all, listen here. Definition of inverse law is, let S be a non-empty set and star be a binary operation. E belongs to S, then there exists B belongs to S, such that A star B equal to B star A equal to E. For all A belongs to S, then we say that S satisfies inverse law with respect to star and B is inverse of A. సో ఇంకొకసారి చెప్తున్నాను డెఫినేషన్. S ఒక శూన్యేతర సమితి మరియు స్టార్ ఒక యుగ్మ పరిక్రియ. S లో తత్సమూలకం E అని అనుకుందాం. S లో తత్సమూలకం E అయినప్పుడు A స్టార్ B ఈక్వల్ టు B స్టార్ A ఈక్వల్ టు E అన్నట్లుగా S లో B అనే మూలకం వ్యవస్థితం అయితే B ను A యొక్క విలోమం అని అంటాము. అప్పుడు ఆ సమయంలో స్టార్ అనేది S పై విలోమ ధర్మాన్ని పాటిస్తుందని అంటాము. S ఒక శూన్యేతర సమితి, S లో స్టార్ ఒక యుగ్మ పరిక్రియ. S లోని ప్రతి మూలకానికి E belongs to S అయినప్పుడు A star B equal to B star A equal to E అన్నట్లుగా B belongs to S వ్యవస్థితం అయితే, B belongs to S అనే మూలకం ఎగ్జిస్ట్ అయితే S అనేది విలోమ ధర్మాన్ని పాటిస్తుంది అని అంటాము. స్టార్ దృష్ట్యా విలోమ ధర్మాన్ని పాటిస్తుంది అని అంటాము. ఇక్కడ వ్యవస్థితమైనటువంటి మూలకం ఏది? B. ఆ B అనేది A యొక్క విలోమం అని అంటాం. B is the inverse of A. For example, here W equal to, so W is the whole number set, పూర్ణ సంఖ్యలు. W equal to 0, 1, 2, 3 and so on. Now star equal to plus. So binary operation is, I am taking here, binary operation is plus. So but you can add the any element in place of W. So then does not there exists -1 belongs to W, such that 1 plus of -1 equal to 0. 1 plus of -1 equal to 0. So what is the identity element of with respect to addition? 0. So 0 is the identity element of with respect to 0. సంకలన తత్సమం 0 అని తెలుసు. సో W లోని 1 అనే మూలకానికి మనము ఏది కలిపితే 0 వస్తుంది? -1 అనే మూలకాన్ని కలిపితే 0 రావాలి. But here existing value is the -1. So -1 is does not belongs to W. So -1 అనే మూలకం W లో ఎగ్జిస్ట్, వ్యవస్థితం కావట్లేదు. కాబట్టి W అనేది సంకలనం దృష్ట్యా విలోమ ధర్మాన్ని పాటించదు అని చెప్పవచ్చు. Because of W has only positive values including with 0. So there is no negative values in W. So W is not satisfy the inverse law with respect to plus. So next I am taking here integer set పూర్ణాంకాలు z equal to 0 comma plus or minus 1 comma plus or minus 2 comma and so on. Now star equal to plus. సో z లోని ఏ మూలకానికైనా మనకు దాని యొక్క ఎగ్జిస్టింగ్ వాల్యూస్ ఎగ్జిస్ట్ అవుతాయి ఇక్కడ. సో 1 plus of minus 1 equal to 0, here minus 1 belongs to z. So 2 plus of minus 2 equal to 0, minus 2 belongs to z. Minus 3 plus of 3 equal to 0, 3 belongs to z. So identity element with respect to addition is 0. So that's why I'm telling here. So there exists b equal to minus a belongs to z such that a plus b equal to b plus a equal to 0 for all a belongs to 0. Huh? Yeah.